So let me just go ahead and show you the process of, so what I'm saying is it's required that you have to have a continuous function on a closed interval, not open, it has to be closed on both sides, on the left side and the right side. Then you're guaranteed to have an absolute max and min in that closed interval. So let's just do an example. I'll show you how the process works as I do an example. Suppose I ask you to find the absolute max and min of this function that I'm about to give you. F of x equals x to the third minus 3x plus 1. So, first you got to find the derivative and the critical values. So the derivative is 3x squared minus 3. Set it equal to 0. And solve for x just like we did before the break. So x equal, I forgot to give you part of the question. On the interval 0 to 3, so that would be provided for you. So this whole thing is part of the question. So the directions would say find the absolute maximum and absolute minimum values of f on the given interval, and I would have to give you the interval. So in this case, it's from 0 to 3. That is required for me to give you. Now, so I got the critical values of x plus or minus 1. So we've got to throw the negative 1 out and just say x equals 1. The reason why we throw negative 1 out here is not because it's a negative necessarily, but because it's not in the interval. So the question said, find the maximum and minimum over 0 to 3. So let's say you have some graph. Here's 0 and here's 3. If I ask you to find the tallest guy and the shortest guy in there, does it really matter what negative 1 produces? No, because it's not even the area that we're talking about, right? I want the tallest and the shortest part of the graph in that interval. So that's why we throw negative 1 out. So now let's list all our critical values, which is only one of them, along with the endpoints. So 0, 1, and 3. So you see the endpoints that are given to you in the problem, they automatically make it to the next phase of the question, plus your critical values. So you list your endpoints plus critical values. We get everybody back, or maybe they're just videos are off, but good. Good, yeah. Some of you are eating, maybe. Madison, eating?
Drinking, actually.
So this is the first example. Were you here this whole time, Madison, or you just had the video?
I was not. I'm sorry. I was in the other room, so I didn't hear you speaking, and I lost track of time.
Oh, it's okay. So we're doing the extreme value theorem, which this is what I wrote so far since the break. So if f is continuous on the closed interval AB, then you're guaranteed to have a maximum. So if you're given f of x equals that function on from 0 to 3, the derivative, you set it equals 0 to combine the critical values. So then I'm going to write this out. We list the critical values along with the endpoints. I should say the critical values that are in the interval. So in this case, it's x equals 0, 1, and 3. Now, here's what you do. You plug every single one of these into the original function, because that's how you get the y value, the original function. The one that gives you the highest y value will be your max. The one that gives you the lowest y value will be your min, and you're done. So the original function is f of x equals, and don't worry, we're going to do several examples, so you'll get the hang of this. X to the third minus 3x plus 1. So what's f of 0? Well, you just plug in 0. And we get an output of 1. What about plugging in 1? 1 to the third minus 3 times 1 plus 1. 1 minus 3 is -2 plus 1 is -1. What about f of 3? 3 to the third minus 3 times 3 plus 1. 27 minus 9 is 18 plus 1 is 19. All right. So now let's look at the y values. Which one gives the highest y value? One second. I forgot how this book likes to write the answers. So the notation they use. So I want to stick.
Professor,
Yeah.
really fast on the previous question above, you crossed out the plus or minus 1. Is that because it's only in the positive?
Yeah. So I didn't, it's not the previous question. It's the same question. But yeah, I crossed out -1 because it's not in the interval 0 to 3.
Okay, thank you.
We're still on the same question though.
Sorry, I just meant above. Sorry.
So 19 is the highest y value that we got. So my absolute max is f of 3 equals 19. And the lowest value was -1. So my absolute min is that f of 1 equals -1. Let me just look quickly in the back of the book here. I use different calculus books in different colleges. I want to stay consistent with how the back of the book writes it so that you guys don't get confused. This is 4.1. No. All right, okay, that they use that stuff. Okay. So that's how they write absolute max and min. So the final answer is right here, the max and the min. So you're guaranteed a max and a min. Sometimes you can have two guys tied for the max. So then they would both be the max. All right, so let's recap what you do when you find the absolute max and min is you find your critical values, then you list them along with the endpoints, and you only list the critical values that are in the interval along with the endpoints. Then you plug every single one of them into the original function. The one that gives you the highest value is the max, that point, and the lowest value is the min. So let's do one more here. I mean, more than one more, but this is the next one. You guys do this one. This is a little bit easy one, I think. So this is supposed to be an x to the third here. Let me make it nicer looking. So f of x equals x to the third minus 3x plus 6 on the closed interval -1 to 3. So find the absolute max and the min over that interval. Hey, June, are you doing okay? Anahi, Elizabeth Vasquez, Miguel.
I'm doing good.
Okay. There's no video, that's all I was wondering.
Oh, sorry, I turned it on.
Hey, good. Okay, you're asleep. It's okay. I already see. I expect someone like the Maris to have their video off, but hey, June, I expected more from you. I'm just messing with you. Oh, have you heard anything, Aliyah, about UCI, if they're going back on campus or not?
No, it's most probably going to be online. That's what I've heard so far as well.
Oh, for next quarter.
Mm-hmm.
I'm
Well,
talking
this
about,
quarter, like, I mean, I start my next quarter in like a week and a half, so that's obviously online. The fall
no, I'm
is
talking about in the fall or like in September or whenever you guys start.
online, supposedly online, but they're looking to, once again, like what you said about Cal State Fullerton, about, the amount of people that get the vaccine and things like that, and then they might change it, but for right now, it's online.
Any of you biology experts? I'm trying to figure out. I need to be studying biology. I gotta ask one of my doctor friends. This vaccines traditionally are like the weak version of the virus. Like let's say like flu season. A weak version or almost dead version of the virus. So your body recognizes it and gets antibodies for it. So now it's ready for battle if it ever gets contact with the virus. But this is a different kind of vaccine. It's something to do with mRNA. It changes the DNA in your cell. So that's why like some people don't trust it. No, I'm not an anti-vaxxer, obviously, but yeah, I was just wondering, so that's what I'm seeing. Some people are hesitant to get it, and it's kind of wondering if anyone has any info about the biology behind the vaccine.
Well, there is one vaccine. So there's 3 in total right now. There's the Pfizer, Moderna, and then this new one came out from J&J or something.
Johnson and Johnson. There's
Johnson
one
and
shot
Johnson.
one. Yeah.
Yeah, that one is it uses a traditional virus approach, I think.
How? It usually takes 5 to 10 years to come up with something like that, no?
I don't know. It's they don't use the exact coronavirus, but they use something very similar apparently.
I'll look into it.
I mean, it takes them that long to do it either way, but I mean, almost every medical scientist or biologist or someone is working on it at the same time. So, I mean, with our technology, it wouldn't take that long if everybody's working on the same thing and sharing information. So I mean, they're supposed to wait 5 to 10 years for the trials, but political stuff, they're trying to get it done. They're trying to just get people the virus, but
Yeah, so here's the thing. Yeah, they could speed it up as fast as they can because they have people working on it long hours. That's for sure. But you still, to know the long-term effects of like what will happen in 5 years, you still have to wait 5 years. There's no way to tell what happened in 5 years. They're not waiting 5 years.
yeah, exactly.
Gotten it yet in class?
I had some students get it that like were working in the doctor's offices. Anyone here?
I got it. I got Pfizer.
I get mine tomorrow. That's why I'm asking.
I'm not sure, guys. I have friends that have gotten it. I have doctor friends that have gotten it. But I'm eventually going to get it too. It's just I'm not in a hurry.
Yeah, I found an article on the Johnson and Johnson vaccine. It's only 1 dose, so you don't have to go in twice.
Yeah, it's 1 dose, but it's only 75% effective or whatever, as opposed to 90 something.
Yeah, I mean, this website, they're saying it's not mRNA. So, I mean, that's one thing to look out for.
Brian, how were you able to get it so quick?
I'm a caretaker for my mom. So my
Oh.
mom's elderly.
Mhm.
So she got it, and then I got it after. They had offered it to me since I take care of her and stuff like that.
So was that your first shot?
No, I'm done. I finished in I think the beginning of February. I was already done. I got my second
Oh, okay.
dose.
How many weeks? You were like 3 or 4 weeks between the 2 doses, right?
It was 3 weeks for my first one. I felt fine. My mom felt fine too, and she's she's 75 years old. You know, she's up there.
Yeah. So
uh,
you guys had Pfizer, right?
we both had Pfizer. Yeah.
Yeah, I'm leaning towards getting the Pfizer one over the Moderna. Was
Yeah.
Bill Gates the one that worked on Moderna? Then I'll get Pfizer. That's it.
Yeah, honestly, I felt fine. You know, nothing aside from just like you know, feels like you got punched in the arm. But other than that, we're fine.
Yeah, Dana. Yeah, I mean, there's some people get like a fever and stuff, but you know, if it's just, but then you know, that's like one day your temperature goes up and then you're fine after that. I haven't heard.
I got mine too, but
Yeah.
I felt like shit the whole day yesterday. And then it went away all of a sudden.
Okay. All right, Damaris. Yeah, thanks. I'll check it out. Okay, let's go over this here. Sorry, I went off on a tangent again. Am I the only professor you guys have that goes off on tangents?
No, we have a computer science teacher, professor, and yeah, he's
Oh, what's his name?
Bloom. Hey Brian, what's his name?
Professor-
Blummerlin?
Leonard Rosenblum.
Yeah, there you go.
Oh, he's probably adjunct. I don't know him. Because I know Dr. or not Dr. but Scott Edwards. He's one of the main guys. Okay. Anyway, take the derivative. Did I give you enough of a chance to work on this, or was I talking the whole time?
It was pretty easy.
Hold on. Miguel, what is the link that you put on the chat?
It's like a picture my sister sent me because she's getting her vaccine. So
Mhm.
it just shows like the effectiveness of the 3 different vaccines and stuff.
Okay. No, because I do have a buddy that is like, I'm not getting it. I'm not going to get it. It's just different people have different opinions on it. But I'm getting it. Let me see how you guys do by end of the semester. I'm just kidding. So x equals plus or minus 1. So now here's the thing. -1 is already included in the interval, so you don't need to list it twice. So those are our possible x values, right? The possibilities. So we're going to go with plug in -1. So that's f of -1. So that's -1 cubed minus 3 times -1. Now I gave you the easy one just so you can see the process. You're going to run into ones where, you know, the critical values might be some effort to find. So -1 plus 3 is 2 plus 6 is 8. F of 1 is equal to 1 to the third minus 3 times 1 plus 6. So that's 1 minus 3 is -2. Plus 6 is 4. F of 3, that's 3 to the third minus 3 times 3 plus 6. 27 minus 9 is 18 plus 6 is 24. All right, so the highest one is 24. So the absolute max is f of 3 equals 24. The absolute min, you look at the y value, which is 4, so that's the minimum. So f of 1 equals 4. So remember, like when you have a graph, the max is the actual y value right here, right? They like, let's say this is 24, and where it occurs at 3 is the location where it occurs at. So if the max is actually 24, where it occurs at x equals 3. Okay, thanks, Mark. Yeah, I actually take vitamin C regularly, and I tried my the vitamin D is actually a very good vitamin to have, just in general, for the people who've got COVID. The people who've had good vitamin D levels have better deal with COVID better. So it's the vitamin that you get from the sun, but we don't get enough sun in our everyday lives. So that's what we need to supplement. And then some people's skin, depending on, they don't absorb vitamin D. I forgot which one was it, the darker the skin or the lighter skin doesn't absorb. I forget. Anyway, you should have your vitamin D level checked. All right, let's do one more here. Oh, by the way, before I do this next one, I want to explain to you why it's important or needed that you have to have a closed interval. So when I say you're guaranteed a max and a min as long as you have a closed interval, here's the reason why. So suppose you have a parabola, okay? If I were to say find the absolute max and min, well, you have a minimum here on this parabola, which is right there, the vertex, but there is no maximum because it goes up forever. So notice if I didn't confine it to a closed interval, then you're not guaranteed a max and a min. In this case, you just have a min only. Whereas, okay, someone else says, okay, well, what if you have an open interval from here to here? So if I confine it to an interval, let's do a closed interval first. So if I did a closed interval, I'm only dealing with that location right here, right? So from there to there. So that means that area is not included. So notice this was supposed to be a parabola, even though it looks like a mess now. So notice if you have your endpoints, which is here, your critical point, which is here, and your endpoint there, notice those are your possibilities where a max or min occurs. So the max in this case would be here, and the min would be at the critical point. So that's the reasoning why if you have a list of all the critical values and all the endpoints, then you have all the locations where it could possibly be a max or a min, because it's not going to occur at anywhere else. It's either going to be at a critical value or an endpoint. In this case, the max is an endpoint, the min is at a critical point. Now, notice how I said you got to have a closed interval, because if it was an open interval and you have that, well, now where's the max at? So let's just say this is x equals 5 and this is x equals 2. So where's the max at now? Because 5 is not an interval. Well, you can't say 4.9, because if you say the max is at x equals 4.9, well, what about 4.99? What about 4.999? And then anyway, we can just keep outdoing each other. So it doesn't make sense. You have to have it closed off for you to be guaranteed a max. So that's kind of like, you can see why the closed interval requirement is needed. Anyway, that's just FYI for you to kind of get a feel for what we're doing. All right, so now let's do the next example. So notice, basically, when you have a closed interval, it's either going to be at the endpoint or the critical value. So that's why we find the critical values, and then we make a list. All right, so f of x equals x squared minus 4 over x squared plus 4 on the closed interval -4 to 4. So we got to find the derivative, and this is a quotient rule. So go ahead and use the quotient rule. Give you a couple more minutes. Aaliyah, just basically the stuff we've been covering. I have to go look at the book.
Okay, no worries. It's just that I won't be in the night class tonight.
Okay, well, just stick around right before this class, then I'll tell you.
All right, perfect. Thank you.
All right, so let's go ahead and do this here. So the derivative is bottom times the derivative of the top minus top times the derivative of the bottom, which is 2x. Let me put that here. All over bottom squared. So we got 2x cubed plus 8x minus 2x to the third plus 8x all over x squared plus. It's very similar to the other one that we did with fractions, but this one, the 2x cubes cancel out. So you got 16x over x squared plus 4 squared. All right, so notice here, again, the denominator here can never be 0, right? I'm just writing it for your notes. So you really just got to worry about the numerator being 0. So when is 16x equal to 0 at x equals 0? All right, so, and by the way, this is continuous and on the closed interval, -4 to 4, that's a requirement. So you do list -4, 0, and 4, and you plug them all into the original. Let's do f of -4 here. So we got 16 minus 4, which is 12. 16 plus 4 is 20, which is 0.6 or 3/5. Now, f of 4 actually gives you the same thing, right? Because you're squaring them, 3/5. And then f of 0, remember, you're plugging it into the original, not the derivative. You get 0 plus 0 minus 4 over 0 plus 4, so you get -1. All right. So the absolute max occurs at -4 and 4. So f of -4 equals 3/5. F of 4 equaling 3/5. They're tied for it. And then absolute min f of 0 equals -1. Assuming the graph of this, the original function, by the way, which was x squared minus 4 over x squared plus 4. I'm going to go ahead and tell you how the graph looks like. I think I got enough info. So the max is at -4 and 4. I'll tell you how it looks like here. So if that's at 3/5, the min is here. Oops, not like that. I need more info, which probably something like that. I need more info to see where it crosses the x-axis. I'd have to set it equal to 0. If I were to set the original function equal to 0, it would cross at 2, actually, and -2. But don't worry, you don't need to know how to graph it right now. So the final answer, by the way, before I went off on a tangent, just trying to see how the graph looks like on my own. That's the final answer. Really liking this highlighter thing.
This is going to be a silly question, but you said the denominator is never 0. Is that going to be only when we're focusing on a fraction?
Well, yeah, if there's no fraction, there's no denominator.
So then we only focus on the top, obviously.
Yeah, because their denominator would just be 1 if there is no fraction, and that 1 is never 0.
Okay, thank you.
Yeah.
I have another question.
You have to worry about the denominator because why a tangent and never a cotangent? Daniel, I don't understand what you're asking on the chat.
I have a question. So in this case, the absolute max, there's 2 values instead of 1. So we would have to put,
because they're tied at the highest point. Yeah. Okay. Daniel, what are you asking? Why a tangent and never a cotangent? Tangent. Is it a joke? I don't know what you're asking. Oh, you go off on a tangent. Yes. Oh, yeah. Okay. So anyway, this is section 4.1. So do the best you can on the homework. I have some more problems I could have done here for you. Well, anyway, number 57 is a trig one. You might have a little issues with that. I can ask about later. Anyway, also, besides 4.1, any of the previous sections that we've done recently, if you have questions on that, I'll have time to go over homework on Thursday. So make sure you come ready with a couple of questions. Aaliyah, do you have anything you want to mention to the class?
Oh, I just wanted to say I didn't have student hours yesterday because I had a final at that time. So tomorrow will be my student hours from 6:30 to 7:30. So if anybody wants to swing by, it changed this week. We do have tutoring after class though.
Okay. Okay, so well, have a fun Tuesday evening, and don't drink too much for St. Patty's Day tomorrow. We have class Thursday. Especially you, Damaris.
Professor, there's no quiz on Thursday, right?
Yeah, no quiz this week.
Okay, thank you.
Bye. Oh,
And when are you posting the study guide for next week?
I'll do it by Thursday night or Friday.
Okay, thank you. And it's gonna be just like the last time study guide, like.
Yeah, same format for the study guide and exam.
Okay, thank you so much.
Yeah, that's the name. I noticed people have been saying STEMI. You guys, make sure when you get your stimulus, don't spend it all in one place. Okay, oh yeah, we're done, by the way. Are you guys looking at me for some info? Yeah, we're done. Bye.